In this session we will calculate the reactions in a frame due to lateral load. So if you look at this frame now, a single frame with the lateral load of 120, assuming this is the wind load, we have our tools, equilibrium tools, which we can use to calculate these reactions, and these are three equations. So the sum of all forces in x direction equal to 0, and sum of all forces in y direction equal to 0, and sum of all moments above certain point xy is equal to 0. These are the three equations of equilibrium. So meaning that we'll be able to calculate three unknowns. And if we look at the reactions in this frame, we have this reaction, horizontal reaction at A, vertical reaction at A, horizontal reaction at B, and vertical reaction at B. So we have four unknowns, which means these three equations will not be able to solve this problem. So we need to reduce, or we need to have only three unknowns to be able to calculate this reaction. So we need to make an assumption, and actually this is from experiments. So the assumption, the first assumption to help us solve this problem will be the sum of all forces, meaning that sum of all the horizontal exterior reactions are equal, meaning that BH and AH are equal. So if we have this assumption, then when you apply the all forces in x direction equal to 0 rule, we'll have a plus P, and then we have minus AH minus BH is equal to 0. And knowing that AH is equal to BH, that will make the equation plus P minus AH minus AH is equal to 0. That means P is equal to AH, and we have only one unknown to calculate with this one. So with that one, I can rewrite the entire thing in this following. I say 120 is equal to AH. That means in AH is equal to 120 divided by 2 is equal to 60 kilonewton. So this is the solution. So instead I can also say that I will assume this is equal to H, uppercase H, and this is equal to H. So if I will rewrite this, because we need to rewrite this in another way, in which way I say is 120 is equal to H plus H is equal to H. That makes 120 equal to H. That makes H is equal to 120 divided by 2 is equal to 60. So same thing. This will be the approach that I will use in calculating these forces. Now what happens if we have now two frames like the following. So if we look at if we do sum of all forces in x direction, you have AH and you have BH and you have CH. So what is now the status of BH? Now the assumption here is, to complete the assumption 1, we'll call this assumption number 1, is we'll say that this is equal to H, and the interior is 2 times H, and this is equal to H. And that actually is represented in the following. We can assume as if the frame is composed of two frames like this, just to keep it, to make it easy for you to think about it. So this is 1H, this is second H, this is third H, and this is H. So you see here the combination here is 2H. So the first rule is, you can write this in your own words, is assumption, let me just do this. Number 1 is the exterior horizontal reactions are equal, and the interior horizontal reaction is 2 times the exterior. That will be the first assumption. So the assumption is that the exterior horizontal reactions are equal and the interior is 2 times the exterior. So if you look at again the frame here, you'll see we can solve the problem, this problem, by, I'll just do this here. So I'll say in this case 300 is equal to, this is 1h, and this is 2h plus 2h, and this is 1h. So 300 is equal to 4h, and h is equal to 300 divided by 4, and it is equal to 75 kilonewtons. So this way we calculated all horizontal reactions. But if you look at the rest of the reaction, you'll see there is also vertical reaction here, vertical reaction here, vertical reaction here. And if we were to have only one bay, it would have been easy to calculate this or this by taking the moment about one of them. For example, in this case, I will take the moment here almost, so I have this will be cancelled, and I'll calculate the value of AV. Then I can use this equation to calculate the vertical reactions. We'll do this in details in the next page. So let's go to to this case. So we need a second assumption to be able to make this vertical reaction. The assumption here is that we imagine this frame as if it is a cantilever, like this one. And this cantilever, you see this side has compression and this side has tension. And if you look at this stress distribution here, you see it gets to the maximum compression here and maximum tension here. And as it changes from maximum compression to maximum tension, it has to pass through a 0. And that 0 is the value, meaning that in the middle is equal to 0. So we'll use that as an assumption. The assumption is that, assumption number 2, is the interior vertical reactions are equal to 0. So with this, we'll be able to calculate now the values. So first step is that, we have the following example to solve using two assumptions. So step number 1 is sum of all forces in x direction equal to 0, which means 300 is equal to, this is equal to h, this is 2h, and this is h. So we'll do that, is equal to h plus 2h plus h is equal to 4h, and say 300 is equal to 4h, and h is equal to 300 divided by 4 is equal to 75 kilonewton. So I can update these values. This is equal to 75, this is equal to 150, and this is equal to 75 kilonewton. Okay, so now if we would like to calculate, now the vertical. So because of assumption number 2, so this means is equal to 0. Okay, so now I will be able to take moments about this point. If I take moments about this point, so step number 2 is sum of moments about point C is equal to 0. So I have the 300 will rotate in this direction, which is positive. Sorry, it is negative. Clockwise is negative. And then I have the AV is counterclockwise, which is positive. And of course, all of these, this one and this one and this one, they're passing through point C, so they will have no rotational effect. This is from statics. So I have only two elements to deal with, so become minus 300, and the distance is 4 meters. This one, and it is negative, plus AV multiplied by this distance, which is 9 meters, is equal to 0. This is not 9 meters, this is 9 meters plus 8 meters, which is 17 meters. Multiplied by 17 meters is equal to 0. So from this I get AV is equal to 300 multiplied by 4 meters divided by 17 meters is equal to excuse me 70.58 kilonewton. So we move on to sum of all forces in y direction, because now we calculated this value. This is equal to 70.58. So I'll apply the sum of all forces in y direction equal to 0 to get this value. So I have equal to 0. I have minus AV plus CV, and of course the value of BV is 0, so I don't need to mention this, is equal to 0. So from this I get minus AV is 70.58 kilonewton plus CV is equal to 0. That makes CV is equal to 70.58 kilonewton. So this is how I solve this problem with 2 bays using these 2 assumptions. Okay, so far we have done all of these frames, and if you have noticed that all of these supports were hinge, and that is not the case normally with the buildings. The supports are fixed. So let's do an example of fixed, and see in this case we'll have beside the 2 reactions, so we have assume this reaction is downwards, and this is of course upwards, and of course these are horizontal ones. So this is AV, and this is AH, and this is BH. Of course there is no horizontal vertical here. This is CV and this is CH, and beside these ones, because this is fixed, so you have moment also, so this is moment at A. There is moment here, moment at B, and there is moment here, which is moment at C. So if you look at these are all unknowns. So we need another assumption to be able to solve this problem, and that assumption is that that this frame will have an inflection point here, an inflection point here, an inflection point here, inflection point here, and inflection point here. Inflection point means it changes, meaning that this will curve like that and like that. This will be like that and like that. So this is the meaning of inflection, and you can see that in the animation if we want to. So based on that, the assumption says, so assumption number 3 is the inflection point points happen at mid heights of columns, if you will, and at mid spans of beams, like so. So I could call these ones Y Y11, and this is Y12, this is Y13, this is X11, and this is X12. Now if you look at this closely, you see I can break this frame at this level and treat it as the following. As if it is hinge. So knowing that, of course I have this 120. So I will have, this is H, and this is 2H, and this is H. Of course I have also forces in this direction. This is equal to 0. Okay. This will be exactly like this. So this assumption will help us to break this frame into two parts, and once you get the first part done, the second part is easy to do, and we'll demonstrate this in an example. So this is how I get these three assumptions, and I'll use them in an example in the next session. So this again will help us say, I will do again P is equal to H plus 2H plus H, and this is H, this is 2H, and this is H, is equal to 4H, and whatever the value of, in this case is 120 kilonewton, is equal to 4H. That makes H is equal to 120 divided by 4 is equal to 3 kilonewton. So this is equal to 30, and this is equal to 60, and this is equal to 30 kilonewton.